Right, I think it's coming up. Okay, sorry for keeping you away from your lunch. You have to bear with me. I hope to entertain you. And thank you, Marcus, for pronouncing my name correctly. You're one of very few people who can do that. Okay, and I would like to thank also the organizers for this opportunity to present this stuff here. I will be talking about a TOM, which was mentioned by Tim already, so there's a lot of introduction, so there will be some repetitions, forgive me that, but I hope you'll find some new stuff in my talk as well. Just to show some faces of people involved, of course, we don't work alone, but our team is actually shrinking in recent years. Practically, there are two people, including myself and Przemek, who are fully working on the project. There is a bunch of students, of course, but students come and go, of course, as we know. And there are some collaborators from around the world. We're associated with Gaia a lot. Many people here are part of Gaia Deepak Consortium. So that's why this work is very much related to Gaia. It's actually started with Gaia, but it's not limited to. So the historical outline here is that at some point, well, you can all agree that there are hundreds of telescopes, small telescopes, and by small I mean from 0.3 to 2 meter telescopes around the world, and they are owned by institutes, research institutes, universities, outreach institutions, even private people. These days they have telescopes which are very often better than the ones we own at universities. So we used that fact already back in 2013, and we gathered these telescopes with the aim of following of Gaia science alerts, which we've been designing in Cambridge. So here you see the sky, the cadence, the number of observations collected by Gaia over nominal 5 years. So if you take an average position somewhere there, on average you get 70 data points over 5 years. So if you do the calculations very quickly, you realize this is extremely sparse. It's great because it's long-term time domain, but it's extremely sparse. On average, we assume it's one observation every month, right? Which is a lot if you accumulate it over the whole sky, but still it's not enough for many of the science cases we can think of. There are some science cases which benefit from this, but this generally is not enough. That's why we gathered these telescopes, and we got support. We've been supported through European Commission grants called Opticon until 2025. And then the people who worked with us, they donated the time voluntarily, depending on their inclusion. I forgot to mention that there is talk of Elme tomorrow about this. You'll hear more about Gaia Science Alerts. I also mentioned that there was a meeting in 2010. Some of you actually been there when we actually, way before Gaia was launched, we started thinking about this in the Gaia Science Alerts context, what to do with all these alerts. And the questions raised here for LSST were already being asked 14 years ago. So we've moved on, but still some problems remained. So the bhtom system itself, it came into life in 2020, and it was based on LCO's TOM toolkit, which you heard about. So this is the global telescope network we talk about here. So you see it's scattered all around the globe. Of course, for Gaia, we need to think both hemispheres. This is the whole sky we're talking about here. So at the moment, we have in our suite 98 telescopes. Some of them are robotic, some of them are manually operated, some of them are private, some of them are institutional. So this is the current status of the network, and I will highlight something what was shown already. One of our first results back from 2016, when we observed one of the Gaia alerts, Gaia 16 AYE. So the black points show you this very sparse cadence of Gaia. This is where the alert came in, and this is when the follow-up started. So here we gathered 20,000 multiband images from 50 telescopes. As I said, they came from with various sizes, and we observed this very target for 2 years. I can't think of any time allocation committee who would give you time for that. If you ask, give me 20,000 observations for 2 years for one star, they would say you're insane. So that's why we are there, and we figured, and this was actually quite a successful research discovery as well, because we managed to fully resolve the invisible binary lensing system which was there. So that was just the beginning of the adventure. So we started this black hole target and observation manager, in short bhtom, black hole because we love black holes, of course. And we started with microlensing as well. It was one of our main science drivers, but we're not limited to that. And of course, we want to find black holes with these observations. So in summary, this is a tool for coordination of the network of time domain observations. And the main feature of it that is we process raw data from all these telescopes, not only from LCO, which we also have, but we process data from any of the telescopes we have. There is automation of data requests and imaging data processing. Of course, everything is kind of in a TOM language. Everything is automatized. We also query time domain archives, and there is a growing number of these. And the data is all available publicly to all registered users. And the footnote here is that we can observe your target, whatever it is, whatever time domain target you can think of, we can observe it. You can add it now, and we can start observing as we speak. So I will also show a block diagram, my version of it. So of course we have all these surveys. They provide alerts, right? Gaia, ZDF, Ogle, ASASSN, LSST, of course. And then there are all these brokers, these beautiful software suites we heard about today. And these come to users. And then users, they can have different questions, right? So this person is interested in supernova in M81, observe it now. And the other person says, okay, please observe this target for 1 year, right? This is my interest. So we see it this way that these people send the observing request to our central unit, bhtom, and then bhtom is taking care of everything else. bhtom is in contact with all these telescopes, and then these people don't see the raw data at all. They don't have to be bothered with all these images flowing from that. And the network and the requests are being taken care here. And then, as I mentioned, there is also the archives coming in, and the archives are being also live or dynamic or static. And then what we produce science-ready data products. We produce light curves, and these light curves are being then fed back to users. And then users, what do they do with them? They write publications, right? So this takes a lot of the burden of the users, which we take care of. Hopefully, actually, we are already ready for replacing users with Raspberry Pis. This is what this system was actually was built for, right? There's of course user interface, but you can actually do everything in our system from your script, and all this data flow, including publication, can be programmatically taken care of. Okay, so this is our target list. You can add targets of any type. As I said, they can be short-term, long-term, bright, faint. You can get targets from, there is a limited list of these, but you can ask from TNS, Antares, Simbat, whatever, or you can add through API directly from your broker. This is a target page. I just show you a couple of examples of light curves. So this is a CV microlensing event, an AGN, or a flare in a quasar. So you see, apart from kind of very contemporaneous data and the follow-up data we have here and here in great wealth, you also see these numerous archives. So you actually immediately have an insight what this target has been doing, and what is this going to do, because we take care of the past and future. The archives, this is just a list of some of them. We find that these archives are sometimes being hidden. Some people forget about them. For example, how many of you know about linear? I guess some of you do, but not everyone is familiar with that. But it is actually a great source of time domain data. The quality of it is, of course, not as good as we would like to, but still, this is something what you can immediately get from our system. We also query the single epoch data, like TUMAS, for example, or SDSS. We also ask radio data. This target actually has some radio observations, which is also very important for some to know. And we're still in the process of adding new archives. The main thing I want to emphasize is that we process images. This is an example image of the Gaia 16 AYE taken with some 60-centimeter telescope in Istanbul. And this is the result of subtracting all the sources we identified there. And this is the curve for the photometric quality. So we have an engine which is called CCD4, it's home-built, developed over years. There is some manual intervention required per telescope. We need to spend some time talking with the people how can we process the data, and then once we set it up, then the processing is automated and it's 99% successful. These uploads can be, of course, scripted, and they are scalable with Docker, so we are ready to accept thousands of images already now. Then we do standardization. If you want to have science-ready light curves, you need to standardize them to something. And here again, Gaia comes as a solution, because Gaia covers the whole sky, and Gaia produced this synthetic photometry archive, which we use. And then we calibrate the data to the best matching system, matching photometric system within Gaia. So you see the light curves of this bright supernova here, or this planetary microlensing event from Gaia. It used to be called Cambridge Photometric Calibration Server, but now it was swollen by the bhtom. Publication, we provide some support towards that. The system doesn't write the papers yet. We're working on it. But then every observation is labeled, is tagged with the instrument and the observer. So we know who did which observations. And it's very often important for some students who actually take part in this program to see their data point appear on the light curve with their name and the instrument. So they get very excited, but moreover, they end up as co-authors of the papers. We produce already about 12 papers. There's 5, I'm aware, are in preparation. Only a handful of them were prepared by our team. Actually, these are people who are not related to us. They just use the system. They observe supernovae. They observe planetary microlensing events. There are also young stellar objects being published from our system. Some statistics, in the very last year, we actually processed 10,000 observations, and this number is actually growing because we actually reached the scalability. We have 55 targets at this very moment, which are requested for observations. It's not a big number, but it can go up, and we can still cope. There are many people asking, give us more targets. We need more, we can observe more. In total, we have nearly 3,000 targets in our system with data. And I just checked that the total number of data points we have, archives and follow-up, exceeds 6 million. It's tiny, right? If you think about the numbers we are getting ready for. And we are already being accessed from all around the globe. But as I said, we are still fairly new system, so it's just the beginning, I hope. So we've been running a series of workshops. As I said, we started in 2010 in Cambridge, but we've been running essentially every year. Last year we've been to Malta. We like nice places with nice beaches. So these meetings are important to keep the community involved and interested, not only in Gaia alerts, that's how we started, but also in all possible time domain science cases with the use of our system. And actually for April, we're planning a dedicated hands-on workshop, mostly for the Italian community, but anyone is invited, in a nice hotel by the beach in Salerno. So please register if you're interested in learning how to use it and tune it to your system. In a summary, I will say that bhtom is a photometric virtual observatory for long-term and varying cadence multi-filter observations of any type of targets. There are no proposals. There is no TAC, no time limit for your observations. bhtom inherits all TOM features. It's broker friendly. It's EON ready. bhtom can process images from any telescope. And bhtom is not a broker. It's the missing link between brokers and the telescopes. And is also not part of the in-kind program, although Poland is part. We provide some different type of in-kind. But however, I think we could talk about some coordination. For example, the Milankovitch telescope has been part of our network, so we've been working with them. So that is something what we can discuss. And we of course have plans to extend to other to multi-wavelength time domain data, radio, X-rays, also polarization curves, astrometry, and spectroscopy. And I Armanda Salerno, and stop here. Thank you very much.
So let's thank Lukasz then. Are there any questions? I've seen one over here.